Welcome guys. So today we'll be looking at resolution of 2D vectors. Right, so what does the word resolution of 2D vectors mean? Before we look at the word resolution, let's look at what the word resultant means. I'll start with resultant. Right, a resultant, let's call it resultant force. Right, what does the word resultant force mean? So when several forces act on an object or a body, they can be replaced by a single force that have the same effect of all other forces combined. That single force is known as a resultant force. That's what you're seeing on your screen there. Therefore, the resultant force is the single force that produces the same effect as the combined effect of all other forces. So what do I mean by that? So let's assume that, let's start from somewhere. Let's assume I have an object of this kind, and then we have two parallel forces acting on it on the same plane. Right? In this case, let's assume the magnitude of this first force is, let's say, 10 Newton. Right? And the magnitude of the second one is 30 Newton. In this case, the resultant force that's going to have the same effect of these two forces is just going to be the net force of these two forces. Since these two forces are acting, right, they're acting in the same plane, on the same plane, the resultant force, our resultant force is just going to be the sum of these two forces because they are acting on the body. So the resultant force is simply going to be 10 Newton, right, plus what? Plus 30 Newton, which gives us what? 40 Newton. That's our resultant force. So it's just the net force of the two forces, right? So you see that the resultant force has the same magnitude and in the same direction of these two forces. If we add these two forces together, acting on the body like two people are pushing an object, so they are pushing a car. Both of them, they are combining their energy and their force. They are pushing with their own force. Combining them, the result they get from both of them is what the resultant force is. Right? So if we add these two forces, we are going to get 40. That means both of them, their effort together is giving us just one force known as a resultant force. Right? And this is for parallel. Let's take another scenario whereby we have two forces that are acting parallel, that are acting against each other. So let's take this as our body, right? And this one is acting with a force of, let's say, 20 Newton, right, to the right, and this guy is acting with a force of 50 Newton to the left. If both of them are acting against each other, where do you think the body is going to move? Of course, the body will move at this direction, right? Because this one is greater than this guy. This force here is greater than this one. So if this guy is acting at 20, this guy is acting at 15. The answer, or both of them, what we're going to expect is that both of them, the body is going to move at this point with a force of what? The force, or with a magnitude of 30 Newton. So this is going to be a resultant force. Why? Because since they are acting opposite to each other, it's going to be what? It's going to be 50 Newton minus 20 Newton. And if we do that, we're going to have 30 Newton. So this 30 Newton is our resultant force acting at this direction. Very good. Now look at the resultant force of these two, because they are acting on the body. Both of them are acting on the body. Combine their force to give us a single resultant force. And if both of them are acting against each other, this one is bigger than this. So if both of them act on the body, this guy is going to push this guy because this one is smaller, and the result is going to push it with what? The magnitude of 30 Newton. Right, so there are two scenarios I'm showing you now. The first scenario is where both forces are acting on the body. We have a single resultant force. Second scenario is when both forces are acting opposite each other. Right, this guy is coming here, this guy is coming here, and then the resultant force gives us is 30 Newton. So let's look at a case where they are acting perpendicular to each other. So in a case whereby, let's assume we have a body acting perpendicular to each other. Look at our body. And then we have a force here. Let's call this force of 4 Newton. And then we have another force here. And let's call this force acting at what? Let's say 3 Newton. Right? In this case, we are going to have what we call triangle of forces. Right? In this case, we're going to have triangle of forces. And what does that mean? To get our resultant, we just draw our line here, and call it our R. So what do we do in this case? We form, and in doing the triangle of forces, we talk about the Pythagoras theorem. We're actually talking about the Pythagoras theorem, where this is our resultant force, the hypotenuse, this is our opposite, and this is our adjacent. Right? So in doing that, for us to get the resultant force of these two forces, by forming our triangle. This is our triangle, right? And we said that this force here is 4 Newton, and this force here is 3 Newton. Forming a triangle of 4, this is our resultant force, right? Our resultant force. So this is our angle 90, and this is our angle. We'll come to this now. So forming our resultant force, we said Pythagoras theorem. Using Pythagoras theorem, in doing that, our r square is equal to what? 4 square plus what? Plus 3 square. That's how we get the resultant. We're going to form triangle of forces, and in triangle of forces we are going to use Pythagoras theorem. And what does Pythagoras theorem state? It states that the square of the hypotenuse is the hypotenuse, right? This is our hypotenuse, is equal to the sum of the squares of both the opposite, is the opposite, and the what? Adjacent. I'll take that again. The square of the hypotenuse, which is our r square, is equal to the sum of the square of the opposite, the 4 square opposite, and the what? And the adjacent. So we can use square both sides. So from here, our r square is going to be what? Doing the square root of if you square 4, we're going to have 16, and if you square 3, we're going to have what? 9. So our r square is going to give us what? 25. And for us to get our arrow from our r square, which is 25, we take the square root of both sides. So that 2, we take off this. Therefore, our resultant is what? Is 5 Newton. And see that the resultant is greater than both this one and this one. You get the resultant force, right? If both forces are acting and perpendicular to each other, what we do is to form what we call the triangle of forces. Triangle of forces, right? And in forming triangle of forces, we use the Pythagoras theorem to find the resultant force. So the first one, if two forces are acting parallel to each other, the resultant force is the sum of both forces. If they are acting to this body, they are acting on this body together, the resultant force is going to be the sum of the both force. And in this case, if two forces are acting opposite each other, they are acting counter each other, we're going to take the difference, that we minus the bigger force from this one, right, to get the resultant force. And resultant force here, we subtract them to get the resultant force. But in the case whereby the two forces are acting perpendicular to each other, one is here and one is here, to get our resultant force, we form what we call the triangle of forces. And in triangle of forces, we are talking about the Pythagoras theorem. I just stated Pythagoras theorem for you. I said Pythagoras theorem says that the square of the hypotenuse is equal to the sum of both the opposite and adjacent. So with that, we have r square is equal to what? 4 square plus 3 square. And 4 square is 16, 3 square is 9. We sum them and do an arithmetic work there. We're going to get 5. So you see how easy it is. I just gave you 3 steps. Although we've not really got into the resolution of forces, I'm just giving you an overview of what a resultant force is. Now in the next video, we're going to be resolving both forces in their components. A force resolving into its x component and its y component. I'll see you in the next video, guys.